Okay, let's finish this guy up. So, part B, is it increasing, decreasing, or monotonic, and is it bounded? So, let's consider the function f of x is equal to 3x minus 1 over 2x plus 2. Let's take his derivative, see what happens here. All right, this is going to be the quotient rule low, d high minus high, d low, all over low, low. All right, so this becomes 6x plus 6 minus 6x minus 2, or minus 6x plus 2 all over 2x plus 2 squared. So 6x minus 6x is a 0, so those are gone. So basically we have 8, which is a positive number, over 2x plus 2 squared, which is a positive number. So we have a positive over a positive, so what we find out is that f prime of x is positive all the time. Well, what that means is our function f is always increasing. Well, what that means is our sequence is increasing. So it's an increasing sequence. Okay, cool. Is it bounded? All right, how are we going to figure this out? Is it bounded? Well, let us list some terms and see what we can come up with. We know that this is increasing, okay? So let's see, what would be the limit as n goes to infinity, or the limit as x goes to infinity of 3x minus 1 over 2x plus 2, and we could use L'Hopital's rule here and find out that the limit as x goes to infinity is going to be 3 over 2, 3 halves. This sequence converges to 3 over 2. So what that means is, yeah, it won't get bigger than 3 over 2. All right. And it is greater than, n starts at 1, right? So 3 times 1 is 3, minus 1 is a 2. 2 times 1 is 2, plus 2 is 4, which is a 1/2. So the smallest it's ever going to be is 1/2 because it's an increasing function. So we can put the or equal to. I don't think it'll ever reach that, but it is bounded. Yes, it's bounded. So it's bounded, and this is what it's bounded by, and it's increasing. Okay, let's see. Yep, okay. Now, let's do the last one and see what can happen there. The last one there, C, goes like this. It's one we've seen earlier, is the cosine one, right? That was earlier in the worksheet. So we've got the cosine of n pi over 2. So base of n is equal to the cosine of n pi over 2. So is this increasing? Is this decreasing? Is it not monotonic? And so let's see here. Remember what this pattern was? It was going around the unit circle, right? And so at 0, it's 0. At 1, it is the cosine of pi over 2, which is 0. And then when n is 2, it's the cosine of pi, which is negative 1, and then it was 0, and then it was 1, and then it was 0, and then it was negative 1, and so on. This is not converging to anything. It is not increasing or decreasing. It's toggling back and forth. So this is not monotonic. However, okay, is it bounded? Well, the biggest it's ever going to be is 1, and the smallest it's ever going to be is negative 1. And so, yes, it is bounded. Yes, it is bounded. So that is all about sequences.